And this video will finish up guided practice 10.9. We're going to be doing problems 8 and 9. 8 is a fairly straightforward type of problem that we've seen before. It involves a secant on the top and a tangent on the bottom. So our formula is for the secant, the outside times the whole equals, and for the tangent, it would be the length of the tangent squared. So the tangent length is 4. That would be 4 squared on the right. The outside part of the secant is x, and the whole part of the secant is x plus 6. Okay, so just like the other problem, we're going to end up with a quadratic situation. So let's go ahead, multiply things out, get to the quadratic formula, and then figure out how we're going to solve it. So we distribute x over x plus 6, giving us x squared plus 6x equals 16. And then we get it into standard form by subtracting 16 from both sides, giving us x squared plus 6x minus 16 equals 0. So let's see how we could factor that, if it's possible to factor it. And again, we're in the same situation that we had last problem, where we have a negative in front of the constant and a positive in front of the x coefficient, the number in front of the x. That means we've got a positive and a negative number that we've got to find. So let's list the factors of 16. 1, 16, 2, 8, 4, 4. I think that's about it in terms of pairs. We start repeating. We could go 8, 2, and 16, 1, but we only want to look at these. The pair that is 6 apart is 2 and 8. So that tells us that if we're going to go and write out our pairs of factors, there's going to be a 2 and there's going to be an 8 here. The question is it positive or negative? We look at the sign in front of the x coefficient. It's a positive. That means the larger number is positive, the smaller number is negative. That gives us x minus 2 times x plus 8. If you want, you could FOIL this. In fact, maybe you should FOIL it just to check for yourself to be convinced that this actually works, that this is actually the factoring. So of course that equals 0, the factors equal 0. We have to set each factor equal to 0 to solve, to find out what the possible solutions are. One solution could be x equals 2, and if we set x minus 2 equal to 0. If we set x plus 8 equal to 0, we get x equals negative 8. Let's go back to the diagram. Let's see which one makes sense. A negative x does not make sense here, so the answer has to be x equals 2. Okay, so let's just confirm that x equals 2 gives us a correct answer. Let's redraw this. If this is 6, this is 2. Remember, this is not to scale. And this is a tangent that's 4. That was a little mistake there. Let's check and see. Is it true that the out times the whole equals the length squared of the tangent? The outside is 2. The whole is 8. Does that equal 4 squared? Does 16 equal 16? You bet. So therefore the answer here is x equals 2. That is the correct answer. Finally, let's do this sort of challenging one. This is similar to one we did in class the other day, or that we will be doing in class if hopefully we've done it in class. This one shows that we've got lots of measurements. Let me try to draw this over. This is the center of the circle. We've got a chord like this, and then we've got a chord coming down through the center, and then we have a radius of length 12. Well, that's very helpful. We know all the radii are length 12. That means this radius from here to here is also length 12. We're told this is x from here to here. We're told this is 8 from here to here. And we're told this is 10 from here to here. So for this chord, we've got 8 times 10. We've got the two pieces broken down, so we can make part of our equation already. 8 times 10 equals. But for this other chord, we have a bit of a problem because we do not know the length between these 2 points. But we know the radius is 12, so the length from here to the circle, from C to the circle, is 12. And we've taken x away from it to leave this segment here. So we started with 12, we took away x, so this piece is 12 minus x. So we can multiply, this is the intersection point, we can multiply this part of the chord on that side of the intersection point by the other part of the chord on the other section. Well, that would be 12 minus x plus 12. So we have to write in here 12 minus x plus 12. Let's go over here, simplify this a little bit. That gives us 80 equals x times. We can combine the 12 plus 12 to give us 24 minus x. Okay, and again we have a quadratic equation. We're going to have to go ahead and we're going to have to handle that and figure out how to solve it. You get 80 equals 24x minus x squared. We do that by distributing. And remember what I said, we don't like to have negative x squares. Whenever you see a negative x squared, you want to put it as a positive on the other side, so we're not dealing with a negative x squared. It's just easier not to have to deal with it. That gives us on the left positive x squared plus 80 equals 24x. And you do want to set one of the sides equal to 0. This already has the positive x squared, so let's subtract 24x from both sides, and that will give us x squared, minus 24x plus 80 equals 0. That is the expression we need to factor. Let me copy it over here. That again is x squared minus 24x plus 80 equals 0. So let's figure out how are we going to factor that expression. Got to look at factors of 80, and we've got to see factors that add up to negative 24. Now, notice the positive and negative patterns here are different. As long as you have one of these being negative, it means at least one of your numbers has to be negative. But to multiply them together and get them as a positive, now it means they're both going to be negative. Okay, you have to have two negative numbers to multiply together to give you a positive number. So let's go ahead and keeping that in mind, let's list out the factors of 80. 180, 240, 3 doesn't go into it. 420, okay, let's see, 5, it would be 5, let me do a little calculator here, I think it may be 16, right? Or is it 14? It's 16, 5, 16, and I could go on and on. However, we already have the pair we need, okay? We said they both have to be negative. And when you add two negatives together, you're basically adding their absolute values and then putting a negative sign in front. So we've got to find two factors that add up to 24 now. Well, 1 plus 80 is 81. This would add up to 42, 2 plus 40. But here we go. 4 plus 20 gives us 24. So therefore, we've got most of our factoring done. In fact, we've got it all done. We know we've got a 4, we know we've got a 20, and we already said they both have to be negative, so we are done. This expression, x minus 4 times x minus 20, has to be set equal to 0, and then we have to solve for all the possible roots for this. In order to do that, we've got to set each factor individually equal to 0. That would give us x equals 4, x minus 20. We add 20, that would give us x is 20. Well, now we've got two numbers, 4 and 20, which either of which or both of which might be solutions. Well, let's go back to our original problem and see which one of those makes any sense. Does 4 make sense? Well, yeah, 4 makes sense over here. That's very good. Looks like 4 could be an answer. What about 20? Does 20 make sense? Well, at first glance, it might make sense. Because after all, x just has to be positive, right? So that's 20. It should make sense. But there's a problem. What's the problem? The problem is that this whole piece, from here to here, has to be the radius. We know the radius is 12. Okay, so something that's a part of the radius, like x, has got to be less than 12. It can't be greater than 12. So x can't be 20, because if x was 20, this piece from here to here is certainly going to be larger than 20, and that's impossible if the radius is 12, because this is the radius. So therefore, we had a logical contradiction if x is 20. The answer has to be x equals 4. So the answer for number 9 is x equals 4. Okay, so you're going to have to do a lot of thinking when you get multiple answers like this. So that concludes our guided practice 10.9.